Hi, today I would like to talk about the Facebook's tectonic file system and efficiency from the exascale. So this is work by the Facebook, Princeton University, and Columbia University. And this guy is the principal investigator. So this is a Facebook work. So all their work and everything is related to the Facebook. So they are talking about the exascale storage use cases at the Facebook. So Facebook is using two kind of storage. One is the blob storage and the other is the data warehouse storage. So what is the blob storage? And the blob storage is when you upload the photos or videos in the Facebook, it is handled by the blob storage. Or when you are sending some attachment to someone in the messages, again, it is handled by the blob storage. And this kind of storage is exabytes of data. So you will be thinking how much exabytes could be. Exabytes could be 1000 petabyte. So what is 1000 petabyte? 1000 petabyte is 1000 trillion byte, right? So and so on. Like what is 1 trillion byte? It is 1000 terabyte. So exabyte is a very huge unit. And several kbs, this kind of file system is like from several kbs to several mbs. For example, you are sending a short video or photos or something. They are compressed and their sizes are like in terms of kbs and mbs. And such kind of things are latency sensitive, so it should be stored as fast as you want, so it's like latency sensitive. On the other hand, they have also the data warehouse. So the data warehouse is taking care of, for example, the machine learning stuff. For example, you are using the Facebook and you are getting some relevant kind of news feed or relevant kind of ads. So all the relevant kind of things that you need and they are coming to you, they are all done by the data warehouse. And again, it is handling exabytes of data. It is handling like MBs of data, a lot of MBs of data. And this kind of service, the data warehouse, is the throughput sensitive. So before tectonic, like this paper is introducing the tectonic. So they are showing the system how it works before tectonic, before implementing the tectonic system. So they are showing both the blob storage and also the data warehouse. In the blob storage, they have two kind of storage tenants. It is also called tenants. For example, this is Haystack is one tenant, the other is F4 tenant, and the Hadoop file system is a tenant. So like different storage things are they are call it tenant in the paper. So in the block storage, they have Haystacks and F4. What is the difference? Haystack is used for hop blobs. When the data is of high frequency, it is handled by the Haystack. Like a lot of one kind of data is retrieved and stored for very frequently. Then in that cases, hard blobs are used, and hard blobs are handled by the Haystack. However, when the data is not that much frequent, then warm blocks are used. Uh, the main cons of the hard block is they are not storage efficient. What does that mean? Since it is input output bound, so input output bound, it takes the input first, it gives the output back. So in terms of that, it is very efficient. But if it comes to a storage, then it is not that much efficient. On the other hand, the F4, it is storage bound. Storage bound means it is efficient in storage, but it is not as efficient in input output operations per second. So you can see that the Haystack, it is good IO performance, but it has lower storage performance. But on the other hand, if you look at this one, the IOPS is bad, but the storage is good. And then in the data warehouse, Facebook is using Hadoop file system. But since Hadoop file system can have like not more than 10 tens of petabyte storage, so they are using multiple Hadoop file system to handle exabyte of memory. Because Facebook is a very huge platform, data from all over the world is coming to the Facebook, so they might have a lot of data. And for to handle that, they are using Hadoop file system. Hadoop file system should be throughput efficient, and they are not efficient for small input-output operations. So what is the main limitation here? All the Hadoop file system, even like they don't have one, but they have multiple Hadoop file system, but they are not considered as one because they are fragmented. This is fragmented from this one. This is fragmented from this one. So it's possible that one of the Hadoop file system has surplus storage, but that storage could not be used by the other one because they are fragmented from each other. And similarly, for example, this one has a surplus IO operations, input output operation per second, but again, those resources could not be used by the other Hadoop system. So this is a very big limitation. So they have three different systems, which is tailored to different workloads. So if they have the data workload, which should be throughput efficient, then it is handled by the HDFS. But if they have like kind of storage, which should be very high frequent, then the Haystack is used. But the problem in the Haystack is it's not storage efficient. On the other hand, if they need some storage efficient memory, in that case, the WAM blobs are used, RF4 is used, right? So to see the whole and the big picture, you can see that everything is distributed. They are decentralized. And because of that, the resources utilization is not good. So to efficiently handle the resource utilization, they have this Tectonic cluster. Tectonic cluster is a kind of cluster which can connecting the blob storage, data warehouse, and everything in one Tectonic cluster. So when it is in one Tectonic cluster, all the resources are accessible. And when all the resources are accessible, then we have a better utilization and we can achieve a good IOPS, and also we could achieve a good storage. But to adopt this Tectonic cluster, they are having some challenges. For example, scalability. Scalability means that they have decentralized and large amount of storage tenants, but they are decentralized. So how can we connect them? When we have all the storage, they should be become exabyte cluster. So can we scale them? This is the first challenge. The other is multi-tenancy. Multi-tenancy means that how can we isolate that this particular cluster belonging to blob storage, this cluster, the storage belonging to the data warehouse storage. Although they did not consider this one in this paper, but this is also one of the challenge. And the third one is the performance. Since dedicated blob cluster, for example, the Haystack or also the F4, when they are doing a dedicated task, they can be much faster and more efficient. But when we connect them all together, can we achieve the same performance by making a Tectonic cluster? So this is the third challenge. So here they address the scalability and the performance. So the first one is the scalability. For the scalability, first let's understand what is this thing. The file is stored in blocks. So each block has 80 MB, and then like there are multiple blocks in one file. And then each block has lot of chunks, where some of them are data chunks and some of them are parity chunks. Now we have like a big cluster of storing data. So they call it chunk store, whether it is blob storage or it is the data warehouse, but they call it all is a chunk store. So and all the storage is here, and on the top of it there is metadata store, which is linearly and scalable metadata storage. And also on the background there is the background services, for example, garbage collector, rebalancer, and fault tolerant, etc. All these things are also working on the background. So let's assume that someone wants to save the file, to save something into the chunk of this storage. So to store the something into the chunks, first there are a lot of directories, and those directories are handled by the name layer. And name layer, by some hashing key value, it can directly access to that particular directory. And then inside the directory there should be some files, lot of files. So again, with the hashing key value, the particular file is tracked. And then after that, each files will have a lot of blocks. So again, with the key value, the particular blocks can be accessed. And again, there could be multiple chunks inside a block. And again, that could be accessed like this. So let's go deeper into this and see how this thing works for reading and writing operation. Let's assume that someone wants to perform the read operation. So to read the file from this storage location, what they are doing, they are first locating what files in a particular path. So there are multiple directories. So the name layer will give that particular directory, and inside the directory a particular file. And inside that file, then it is going to track which one blocks in that file. So the file layer will directly track that particular block, and then it will again check for block of list. So once it understood that this is the particular block of list which I have to read, which is serviced by the block layer, it is requested here, and from their block of list the information are retrieved, and those information are given to the output. And all these information are handled by this client library, which is the core part of the Tectonic. Now, someone wants to perform the write operation. To perform the write operation, which means they add a block to the file. First of all, they go to the block layer directly, and inside the block layer, it check for which one node has a suitable location where I can store the data. It can be like very hot data, or it can be like warm data. So depending on that, the block layer will check the suitable nodes for that, and inside that the data is stored. Once the data is stored, then all the information related to the storage data is given back to the block layer, that I have stored the particular data in those particular block location. And once that is done, all the block information are also given to the file, that please add this particular block location to this particular file. And once that is added, a success notification has gone to the user that your data has been written. Now let's check how they are working with the performance. So performance mean they should match the specialized subsystem. Specialized subsystem mean they are using Haystack, they are using F4, and they are using the HDFS. So can the whole Tectonic cluster achieve the performance of the specialized and dedicated Haystack, and specialized dedicated F4, and specialized dedicated HDFS? So the specialized storage system optimizes for specific access pattern and performance requirement. Tectonic uses tenant-specific optimization to match the performance of specific subsystem. So it check like which tenant-specific optimization is needed, and based on that, Tectonic will control the storaging operation. And then again, the optimizations are enabled by the client library. As I told, like the client library is the core part, which handles all the read-write operations, which runs in the application binary. And the client library allow flexibility and varying composition of Tectonic operation, which can be configured according to the need of tenants. So whatever the tenants need, client library is handling that very flexibly. So what is tenant-specific optimization? So here they have compared the warehouse storage operation and also the blob storage operation. So in the warehouse, the files are very large, like they can be hundreds of MB, whereas in the blob storage, it's short files like photos or videos or something. So they can be hundreds of KBs. So in the warehouse, first the data is appended into the buffer. So once the data is appended into the buffer, they are transferred block by block to the compressor or encoder. And after the block by block data, it is compressed and stored in a particular memory chunks. For this appended data in the buffer, the files are read, and after they created, close the files, then it is checked whether the block is full or not. As the block is full, it is transferred to the compressor. And the goal of all this operation is to maximizes the throughput, because in data warehouse, high throughput is desired. In contrast, this blob storage, it handles the small blobs of chunks. So first of all, it replicates this in 3 ways. It takes the small data, and then it replicates 3 times in a particular block. And then it keeps checking whether the block is full or not. As the block is full with the data, then that block is read again. And since it contains 3 replicated data, then it is compressed. And finally, the stored chunks are stored in the particular locations. So in the results, since Tectonic cluster merges everything together, so it is 10 times of the HDFS cluster, which simplifies the production operation. And the blob storage latency in Tectonic is comparable to the Haystack. So it is as fast as the Haystack operations. So again, they are achieving this one. And then in a multi-tenant cluster, data warehouse uses surplus IO from the blob storage to serve its peak. What does it mean? Let's go and check it in the result. So here it is the time in hours, and it is the number of input output operations per second in kilos. So if you look at the blob storage operation, it is almost consistent. It doesn't have like very sharp peaks, so it remains consistent, and it always have some surplus IO available. But when they have the data warehouse operations and the peak time, sometimes they need some they have high peaks, and sometimes they are fluctuating, like they have low requirement. When they have high peaks, it require surplus IO. So when they require the surplus IO, they can borrow those surplus IO from here, from the blob, and it can be effectively serviced. And when they don't need that surplus IO, then it can use its own resources, whatever it has. So the surplus, the resources which were surplus from the blob storage, they can be effectively utilized by the data warehouse. So The Tectonic provides data center scale storage. So the data center scale storage is provided by the Tectonic, and it has simpler operation, and also it has better utilization. So the Tectonic has address two key challenges. One is the scalability, and the other is performance. So this is the conclusion of this paper, where they have solved these two problems. Before winding up, I would like to answer three questions. The first one is why the problem is important. The problem is important in the distributed file system. We could not efficiently utilize the resources. So even if we have like a lot of resources available and they are surplus, but we could not effectively use them. One operation cannot borrow operation from the other. What is the novelty of this work? The novelty of this work, they devised the Tectonic cluster. Tectonic cluster connect all the tenants together, and the resources can be borrowed from one tenant to the other tenant, and thus the overall efficiency increases in terms of utilization. And what is my impression? So let us first check. This paper is very recent. It has been published in 2021. So they haven't got like more citation for now. But I think the work is very good, and it is supported by the Facebook. And this principal investigator is also working on facebook.com. So I think this could be an effective work because the problem they are solving is a good problem. And I think I like this paper.